Well, alright, Dasha. Like a fool, did not make the recording while I was going through these in class, so you get to see things and listen to me talk about them. I'm going to start with the fourth quarter review this is number 4. And what it is two vectors. One has a magnitude of 300 newtons, the other has a magnitude of 400 newtons, and the resultant vector has a magnitude of 600. And alright, and what we want is this angle between the two vectors. Well, this is a law of cosines problem. We have the angle theta and the side opposite it, so 600 squared equals 300 squared plus 400 squared minus 2 times 300 times 400 times the cosine of that angle theta. And when you do all that and solve for theta, you should get 117.3 degrees. Alright, now moving on to number 5. From semester 4, what they told us was that we had a resultant vector with a magnitude of 50, and it was at an angle of 75 degrees. One of the components had a magnitude of 65, and it was directed at 280 degrees. Well, we know that if the resultant is A plus B, well then B must equal the resultant minus A. So what we do is to find the I component, we take 50 times the cosine of 75, that's the I component of the resultant, and subtract out 65 cosine 280. That's the I component of the A vector, and that gives us 1.654. To find the J component of B, it's 50 times the sine of 75, that's the J component of the resultant vector, minus 65 sine 280. That's the J component of the A vector. So B has a J component of 112.309. So that tells us that B is 1.654I plus 112.309J. Now to find the magnitude of B, it's the square root of the I component squared plus the J component squared and the square root of all that. And when we do that, it's 112.321. That's the magnitude of B. Now the direction, the angle, is the inverse tangent of the J component divided by the I component, and that's 89.156 degrees. Alright, now let's see, the next one we looked at was, this is actually number 4 from the third quarter review, which is the 0.5 sine 2x minus pi plus 3. And they ask what the period is, and the period is always 2 pi divided by the frequency, and the frequency is that value that we multiply x by, so 2 pi divided by 2 is pi. Amplitude is always this leading coefficient, so the amplitude is 0.5. Phase shift is pi. Midline is always the constant that's added at the end. This time it's 3. The minimum is going to be 2.5. The maximum is 3.5. Well, if I put 3 here, 2 there, 4 up there, and I start my wave right here, it goes up and down in a matter of pi units. That's our one period. Okay, so that's what the graph should look like. Let's see. Now, the next one I believe is, yes, number 7. Here's a nice picture of that. And we want to find a positive sine or cosine graph. And they ask for a few different things. The easiest thing to look at for this one, I would say, would be to make this a sine graph, because if we start right here on the y-axis, go up, come back down, and go back up, from here to here represents one cycle. And when we do that, that makes that phase shift phi 0. Okay. Now the period is how long it takes to get from here to there, and if we look at that, we start at 0 and we go to 2, so the period is 2. Now the frequency is going to be 2 pi divided by the period, so 2 pi divided by 2, the frequency is pi. Amplitude is the distance from the midline to a peak, or the midline to a trough, which in this case is 3. It's shifted up 1 unit, so that k value is 1. So the basic equation, the parent equation, is a times the sine of fx, f is frequency, minus phi, phase shift plus k. Amplitude, frequency, shift up and down, phase shift is 0. To turn this thing into a cosine graph, we would have to start up here, and we would go to there, and the phase shift then would be 1/2. Right, whichever one is easiest for you. Okay. Now moving on to number 13 from third quarter, it's the inverse sine of the cosine of 2 pi over 3. Now, the cosine 2 pi over 3 is negative 1/2. So what this really is the inverse sine of negative 1/2, and that is negative pi over 6. Another way to write that would be 11 pi over 6, or negative 30 degrees, or 330 degrees. Any one of those is fine. Let's see. Moving on. Oh, number 15. The sine of 165 degrees, I thought of that as the sine of 330 degrees divided by 2. And then I looked on the formula sheet, and I got plus or minus 1 minus the cosine of 330 degrees divided by 2. Cosine of 330 degrees is the square root of 3 over 2. And I would leave it just like that. Not the only way you could do that problem, that's just the way that I did it. Next one I would look at would be number 17. And that's the tangent of 150 degrees. And I thought of that as the tangent of 90 plus 60 degrees. So that becomes the tangent of 90 plus the tangent of 60 degrees minus tangent of 90 times the tangent of 60. Now the tangent of 90 is 1 over 0, which is undefined. Okay, so you could say that this is undefined, or if you really wanted to, what it comes down to is the tangent of 60 degrees, which is the square root of 3 over 3. Okay. Let's see here now. Looking at the next one, number 19, we were given this. The cosine of 80 degrees times the cosine of 20 degrees plus the sine of 80 degrees times the sine of 20 degrees. Okay, what this is this is the formula for the cosine of a difference. And it's the cosine of 80 degrees minus 20 degrees, which is the cosine of 60 degrees, and that equals 1/2. Now, remember, you can use that sheet with all the trig identities and the unit circle on it, so you can look at those. Now, the next one is number 27, and that's the sine of 2 times the inverse cosine of negative 3/5. Now what I did was I said that the inverse cosine of negative 3/5 was equal to some angle theta. So then that gave me the sine of 2 theta, which is this. I can then use the double angle formula, 2 sine theta cosine theta. Again, that's on that sheet. But what's theta? I use the fact that cosine theta equals negative 3/5, Right, I just take the cosine of each side here. So that would give me negative 3 over 5, or adjacent over the hypotenuse. That makes the opposite side 4. So the sine is 4/5. The cosine of theta is negative 3/5 times 2, and that all comes out to negative 24 over 25. Alright, 31. We were trying to prove this. Sine theta tangent theta plus cosine theta equals secant theta. Well, the first thing I do is write everything in terms of sine and cosine, which means I'm going to write tangent as sine over cosine, and secant is 1 over cosine. Now, sine times sine is sine squared over cosine. Now, to get a common denominator with this cosine, I need to multiply by cosine theta over cosine theta, so that gives me cosine squared theta over cosine theta. Sine squared plus cosine squared is 1. The common denominator is cosine theta. That is finished. The next one we want to look at is number 34, and that's the cosine of 3 theta plus 3 equals 2. First thing I do is I subtract 3 from each side, and then what happens is I get the cosine of 3 theta equals negative 1, and then I take the inverse cosine of each side, and that tells me that 3 theta equals pi. Divide each side by 3, and theta equals pi over 3. And the last one we looked at in class was number 35. And that's 2 sine squared equals negative sine theta plus 1. First thing I did is I moved these things to the other side of the equal sign. So I got a plus sine theta and a minus 1 equals 0. Now this is a quadratic expression, and it will factor. And it factors into 2 sine theta minus 1 and sine theta plus 1. So 2 sine theta minus 1 equals 0, or sine theta plus 1 equals 0. We're just using the zero product property here. Either this thing is 0 or this thing is 0, if the whole thing equals 0. So add 1 to the other side, divide by 2, I get sine theta equals 1/2. Inverse sine of each side, theta equals pi over 6. Move the 1 to the other side, I get sine theta equals negative 1. Inverse sine of each side, and theta equals 3 pi over 2. And that should do it. If you concentrate on those problems, you should do okay on the final exam. Let me know if you have any other questions. Shoot me an email, or come see me when you get to school, whatever. Have a good night. Hope you feel better. See you tomorrow.